Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, average waiting time. So we have a restaurant with a single chef, and we get a list of customers. And the data we get for these customers is their arrival time at the restaurant and the time it takes for the chef to prepare their meal or whatever they requested. Um, Now, when a customer arrives at the restaurant, the chef takes their order and prepares it once they are idle. Okay, so if they had a previous order they were preparing, they wait until they are done, and then they start preparing the new one. And the chef can prepare only a single order at a time, right? And so and they also prepare them in the order of the input, so you can assume the arrival times here are sorted. And the goal of the problem is basically to return the average waiting time for every customer, for all the customers. So basically we take the waiting time for each of these customers, we sum it up and divide it by the number of customers. That way we get the average, right? So that's pretty much it. Now taking a look at the first examples just to get an idea of how this works. So this customer one arrives, and so we start them off. The shift starts at time 1, and then they prepare it. It takes 2 seconds or minutes or whatever. It takes 2 units of time, and so at time 3, their order is done. And so once once they are at time 3, they can take the second order. And so you can see the second customer arrived at time 2, so they already had to wait 1, right? Between 2 and 3 for the chef to start their order, and then the chef starts. So they have to wait. So 3 plus 5, their order would be done at 8. And so they had to wait from 2 to 8, and so they had to wait 6. The first one started at 1, and their order finished at 3, so they had to wait only 2. Now for the second one, they arrive at 4, but the previous order ended at 8, okay? And so only at 8 that we can start. And so so 8 plus 3, that's 11. So their order will be done at time 11. And so we do 11 minus 4 to get how much time they had to wait. So they had to wait 7. And now we just add up all 3 numbers, okay, and divide by the number of customers, which is 3. That would be basically 15 divided by 3, so 5. Okay. So that's roughly the idea. Now how do we do it? Well, we can actually just do the exact simulation that we saw in this first example, which is basically we just need to keep track of the current time, which is basically time, for example, here you see time 3, time 8, time 11, and then we keep track of that current time, and then every time we subtract that from the arrival time to know how much they had to wait, and then we add that to our sum, and then at the end we divide our sum by the number of customers, right? So pretty straightforward here. It helps that this is already sorted, because we need to process these already in the order we get in the input. So we don't need to sort. And so we get arrival and we get prep time in this customers array. Now we need to have like the sum of the weights for all customers. That's something we need to initialize. And then at the end we can just take that and divide by the number of customers to get the average, right? And now we need to know the current time, okay? The current time, this is basically the current time from the point of view of the chef. And so here, the current time should be basically, let's say if arrival was bigger, let's say the current time is 2, and this customer arrived at 4, then we want the current time to be the arrival. But if the current time is 5 and the arrival was at 3, we want the current time to still be 5. So whichever is bigger is the time the chef will start preparing the order, right? And then we need to do plus prep time. So this is basically we update current time to be the time the chef starts order and prepares it for this customer, right? Okay. Now, once we do that, how much time did this customer have to wait? Well, remember, current time is the time it took for the chef to start, so to finish the previous order and start this new one, plus the prep time. So the wait time for this customer, let's just have it separate. So the wait for this customer is going to be the current time. So the current time is at the end of the order preparation, right? Minus the arrival time, right? Because they arrived at this time and the chef was able to finish their order at this time, so they had to wait the difference, right? And then this is what we need to add to the overall sum of wait times. Okay. So this, just to make this clear, so this is basically time order prep start, right? And then we add it to the prep time. Now, why is this the maximum of the current time and the arrival time? Well, the current time is basically the previous orders end time from this, okay? We can even make that even more clear. Previous order end prep end time, okay? So if you take that, then the time that the chef would be able to start the order is the time of the previous order end time, where the chef will be idle, and the current arrival time, whichever one is bigger. And then we update it so that for the next order, the chef can start only after the current order is finished. So we add the prep time, right? And then the wait time for the customer is just the time it's just this time minus the arrival, right? I'm just naming the variables here in an expressive way so that you can understand. I hope that helps. But this is the wait time for this customer. We add it to the overall wait time, okay? We can actually call this current order prep end time. Maybe that would help, okay? And then we divide by, once we get all the weights, we divide by the length of the customers, right? So basically we keep track of the time the chef finished preparing the previous order. That's what we have here. And then for the next customer, that's the minimum time they can start at. But if this customer arrived later, we have to start only when they arrive. We can't start before they arrive, right? And then for the wait time, it's just the time we start preparing, the time they arrived at, and the time we finished preparing their order. That's their wait time. And then we add it to the overall wait time and then get the average. So if we run this, looks like, I think I messed up just the names, so this needs to be the same. Okay, and we can submit. And this gets accepted, okay? Now, of course, if you wanna, once you understand this, you can change the naming just to be shorter and to be easier to process. So this would be current, and then this would be just plus this prep time. That would be the current time. And then the weights would be just the sum of this. We don't need a variable for that. And so this needs to be just the current time, right? And that's pretty much it. And this works, okay? Now in terms of time complexity, this is just linear in the length of customers. So it's O of n, n being the number of customers. And in terms of space, it's O of one space. So O of n time O of one space. Yeah, so that's pretty much it for this problem. Thanks for watching and see you on the next one. Bye.